Support for the Alan L. Edwards Psychology Lecture Series is provided by the University of Washington Alumni Association.
It's quite an honor for me to introduce our next speaker, Professor David Budescu, who comes to us tonight from Fordham University in New York. Now, he received his bachelor's degree in psychology and statistics from the University of Haifa in Haifa, Israel. And then Dr. Budescu then received his master's and Ph.D. in quantitative psychology from the University of North Carolina at Chapel Hill. And that was in 1980. Now, Dr. Budescu then moved to the University of Haifa as a lecturer, and then was quickly promoted to a senior lecturer, and then on to an associate professor there. And then in 1992, Dr. Budescu came back to the United States, where he was an associate professor at the University of Illinois in Urbana-Champaign. He was promoted to full professor there in 1995, and then in 2008, he moved to and has been since the Anastasi Professor of Psychometrics and Quantitative Psychology at Fordham University. Now, Dr. Budescu has quite an illustrious career in the general field of decision-making research. He has explored many aspects of how we make decisions in everyday life, and particularly, he's been interested in the influence of your perception of the outcomes of uncertainties, about the influence of the perceived uncertainties about the outcomes of our decisions. Now, his work is published in the very best journals and influential books in his field. Now, his expertise is highly sought after, as is evidenced by the fact that he has served on many prestigious editorial boards of journals as well as grant review agencies. Now, Dr. Budescu has also been the past president of the Society for Judgment and Decision Making, and he's currently a fellow of the American Psychological Society. Please welcome Professor Budescu.
Thank you very much. First, I'd like to thank you for inviting me. It's both an honor and a pleasure to be here and to have the opportunity to talk to you about some of my recent work on judgment and decision. And I want particularly to thank Susan for doing such a wonderful job of basically setting up the scene and the stage for some of the things I'm going to talk. And although my work is slightly different in focus, you'll see that many of the themes that ran through her talk are going to emerge again in slightly different context. So tonight, I'm going to talk also about probabilities, but actually, as you can see from my subtle title, I'm going to try to focus on the situations where probabilities are imprecise and not fully known. So probabilities were supposed to be the communication, the mode by which we communicate uncertainty are in themselves uncertain. So if the time permits, this is what I like to do. I like to start with some background and terminology to talk about this notion that people are averse to imprecision or vagueness, the way I call it. And I'm going to try to question the generality of this result by asking myself, how general is vagueness aversion? Ask whether situations where people actually prefer imprecise information. Ask whether all the uncertainties that look alike on paper are actually affecting people's decision in identical ways. And then the second half of my talk is going to be on a totally different topic on communicating probabilities and uncertainty by means of natural language rather than number by terms such as likely, unlikely, very probable, and so on. So I want to make two general comments before I continue. The first is that whenever you give a lecture of this type, you always have to make a decision on the trade-off between how much you want to cover and what level of detail and how much technical details you want to include. And I opted clearly to cover as much as possible, and I'm going to skip a lot of technical details. I'll be happy to talk about all of them with you. The other thing is that you'll see that many of my examples that I'm going to use are either in the context of global climate change or at least inspired by global climate change. So I've become interested in this topic of climate change and started working on it from this perspective. I'm not a climate scientist. I don't want to make any claims to that effect. But I think climate change is a wonderful application for the kind of work that we are doing about uncertainties. If one had to invent an ideal case where there are multiple uncertainties, deep uncertainty, hard to quantify uncertainties, one could not do better than what we have right now in climate change. So therefore, many of the examples are going to be in that context. Having said that, I think that everything I say applies to any other context as well. And in fact, just next week, I'm going to give a similar talk to the NTP National Toxicology Project, where they are concerned about communicating uncertainty about toxicology, but the same principles apply. So traditionally, in decision theory, we are distinguishing between individual decisions that are being made under conditions of certainty, risk, and ignorance. Certainty is basically when you have to choose between a new Toyota, a new Ford, a new Chevy. Once you make a decision, once you are crystallizing your preferences and you make a choice of one of the cars, there's absolutely no uncertainty because probability play no role. Decision under risk are the kind of decision that Susan talked about at length in the previous talk, where the probability and you need to make the decision whether to salt or not to salt the road, which investment, which retirement plan to take, and so on. So these are done by combining outcomes, expected outcomes, and probability. And we also talk about decisions under ignorance, where we realize that probabilities play a role, but unfortunately we have absolutely no information about ignorance, about the probabilities. So if you look in many books in decision theory, they're going to be organized by this typology. But in fact, this typology is just represent a few selected points on a continuum, and many, many situations, like the ones that I'm going to talk about, are going to be somewhere in between. Somewhere in between decision under risk and decision under ignorance. And here's some example. Situation where people are confident and can tell you, I can rank these possibilities in terms of how likely they are. The most likely, the second most likely, the third most likely, to the least likely, but I cannot put probabilities of them. So there are many probability assignments that will be consistent with the rank, but people cannot come up with one. Situation where people are very comfortable saying, I think the probability is going to be at least 20% and at most 55%, but they cannot be more precise. So lower and upper bounds. Or situation where people are just categorizing everything in fuzzy categories, such as it's going to be in the 60s or it's likely. So these are the kind of situations I'm particularly interested in. I want to talk, again, in terms of kind of setting up the stage and terms, about three sources of uncertainty, of imprecision, when it comes to communicating uncertainty. One is the event itself. Quite often, we are interested in events which are in themselves imprecise. I'm going to use the terminology ambiguous and unambiguous to define events, and I'll give you a couple of examples in a second. So an ambiguous event is one which different people may interpret it in slightly different ways because the nature of the definition is imprecise. The second is the type of uncertainty. How accurate is the uncertainty? So on the one hand, you have the most precise situation is what I called earlier decision under risk, where you know we can specify how likely each one of the outcome is, and then you have other situations where the information is insufficient to allow you to specify probability. These are some of the examples I gave. And sometimes it's not only because you don't have the information, but sometimes the nature of the event, and climate change is such a case, that the uncertainty is just irreducible, just have no way of obtaining the kind of information we want, so you have to take into account the degree of irreducible uncertainty that operates in the background. And the third dimension is what's the how precise or imprecise is the language that you use to communicate uncertainty. So you have these three dimensions, each one goes from very precise to very imprecise. The interesting thing is that they are not independent. They are related to each other, and I'm going to try to illustrate this through two examples. Imagine that someone tells you the following. The chances of an abrupt drop in the market in the near future is going to be 0.238. Now, this is an ambiguous event because different people may interpret abrupt as well as near future differently. Because everything we know about the market tells us that it's very, very hard to quantify the uncertainties about the market at such precision, and yet, whoever wrote this statement, me, selected to make it a very, very precise, much more precise than it's reasonable to expect. On the other hand, imagine the following. The chance of drawing a queen from a fresh deck of cards is low. Now, why would that be the case? This is an unambiguous event. The probabilities are easy to quantify by simple enumeration, and you would expect in such case that the probability judgment will be equally precise. And so these two basically set the stage for what I call the congruence principle, which is that uncertainty should be communicated in a way or in a modality or the level of precision which matches the nature of the event and their uncertainty. And I want to make this statement not only as a prescription, here's the way you do it, I also want to make the claim that most people are actually behave this way, and that is a description of what they expect from forecaster and communicators. So next I'm going to talk about a version to vagueness or imprecision. In decision theory, this all goes back to something we call the Ellsberg's paradox. Many of you may know the name Daniel Ellsberg as the person who in 1967 or 68 leaked to the Washington Post and the New York Times the famous Pentagon Papers about inaccuracy in the way the Johnson administration was reporting about the war, and he became #1 on President Nixon's list of enemies. But before he did this, he wrote this brilliant, he is a Ph.D. in economics, he wrote this brilliant paper based on his dissertation about decisions under what he called ambiguity, and I'm calling vagueness. And to understand what he did, think of the following thought experiment which he used in his experiment. There are two urns filled with balls. There are 100 balls in each one of them, and they are either red or black. One urn, the one on the left, I'm telling you there are 50 of each color. The other one, all I'm telling you, and you cannot see the content, you just have to trust me on that, is that there are 100 and some of them are red and some of them are blue. But you don't know the composition of the urn. Now I'm going to say the following. If you draw a red ball, you win $10. Would you rather draw a red ball from the urn on the left, the one on the right? And Ellsberg speculated, and most people agree in their behavior, that people tune the one on the left. So in other words, they behave as if they think the probability of a red in the vague urn is less than 50%. 10 minutes later, you can come to the same people and ask them the following. Now I'm going to draw a black ball. And if you get a black ball, you're going to win $10. Which urn would you rather draw from? And again, most people, and Ellsberg speculated, will draw from the urn on the left. So if you take these two together, that implies that people are behaving as if they think that the probability of a red plus the probability of black on the right-hand side are less than 100%. So it's a violation of the basic principle of probability. And his point was that to understand decisions, it's not enough to know in some cases, it's not enough to know the outcomes and the probability, but also to be sensitive to the source and precision of this information, and that it makes a difference. And there are many ways of explaining the paradox. This is a partial list of explanation. I'm not going to go into them. But just to make the point that when people say Ellsberg paradox in the same sentence immediately complete, people do not like imprecision. Everything else being equal, people always prefer precise information. So I'm going to try to put some limits and some bounds on this overgeneralization. First, I'm going to ask myself, how prevalent is this pattern? Does everyone do it? Does it happen all the time? So here's the result from a study that my former student Karen Kramer and I did a few years back. And let's simply look at the column that's called overall. Basically, we had about 70 participants. Each one of them made 16 or 17 choices, pairs. Once you have to choose if red paid, once you have to choose if black played. And then we were paid, and we were able to classify every individual according to whether they were showing vagueness avoidance, which is the first line, the line in red, which is the Ellsberg outcome. And you see, yes, it is the most likely one. It happens more often than any of the others, but it only happens about 35% of the cases. You see that about 23% of the choices that people make are actually consistent with the theory. So in other words, they say, I'll take the one on the left for one, and I'll take the one on the right for the other. So they act as if they think that the probability of red and blue in the second are not the same. There are about 14% of the people who basically say, I'm vagueness neutral. I don't care. I don't care if I draw from the urn on the left or the one on the right, so the fact that I know more about one doesn't affect at all my choices. And there is also a minority, about 10% of the people, who actually consistently prefer the one which is imprecise. Okay? So two lessons to take away from that, namely that vagueness aversion or imprecision dislike is there, is strong, but it's far from being general and being universal. The other one is that it's kind of rather fragile. If you were to run this experiment, and people have done it, where instead of you win $10, it's about losses, then the strength or the intensity of the dislike for imprecision is reduced. And also, if you look at the last two columns, if instead of saying the urn that you understand is not 50-50, but it's rather 80% of one color and 20% of the other color, then the proportion of people who are actually consistent choose one for the red and the other for the blue increases dramatically. So the first lesson from this example is that imprecision is not a vagueness to imprecision is not that general. Here's a second experiment in which we are not, instead of comparing how people look at precision versus imprecision, we want to see how people are making decisions when the probabilities are only partially known. So the way we operate, we did this experiment, is by basically saying there's an urn, and if you came to the lab, there were urns of this type, and for example, you could see the number 40 on one of them, meaning that we've already put 40 balls on it, some of them white and some of them red, but you didn't know how many. If you wanted, you could put your hand in and count. There are 40s, but you couldn't see their colors. And then we tell people, okay, 40 are already in there. Now, here are two jars filled with white and red. Please count another 40 red and put them in, another 20 white and put them in. So now, since what you know is the probability of a red is at least 40, because you counted 40, and at most 80, okay? So that's a way to induce, operationalize, convince people that they know lower and upper bound of probabilities, but not the precise probabilities. And what we wanted to see in this situation, how do people make decisions? And they had to choose one of three actions. One is what we call the risky choice. Basically, said you're going to take the red ball is something which is undesirable in this case. If you get red ball, you're going to be penalized. You draw two balls. If they are both red, you lose everything. You can avoid this unpleasant situation by agreeing to pay a fine up front. And if you pay this fine, then you don't even have to bother withdrawing because you keep whatever is left. Or you can simply reduce the risk. It's almost like an insurance policy where you pay a smaller fee up front, and then you draw balls. And if both of them are red, which is the situation in which normally you would lose everything, because you have insurance, you're not penalized immediately, but you're given the choice of a third draw, and only if all three are red, you end up losing all the money. So this, for example, these are the consequences of these three policies. In this case, the probability of a red is between 0.2 and 0.8, and these three curves show you what will happen for the blue one, the steepest one, is in the risky decision as a function of what the true probability is. The flat line is basically saying, since you pay the big fine, you always get the $6. And the green one is basically the reduced risk. And you can see if you knew, okay, I'm going to violate a rule. If you knew you're here at 0.2, then clearly it pays to take the risky decisions because the probability of losing everything is very low. If you're at the other end at 0.8, clearly the best thing to do is to pay the fine up front and not to bother with the risk. But there are other cases where the best outcome is the green line. Now, the point is that you don't know ahead of time whether you're 0.2 or 0.3 or 0.4, and you have to make a decision ahead of time. And so what we find when I said this was inspired by climate change. I want to explain how this was inspired by climate change. The risky decision is basically our lab analog of business as usual. Don't do anything. take the risks that are associated with climate change without doing anything to mitigate them. The riskless decision is to take very, very aggressive and costly action immediately and to minimize the probabilities of the worst case scenarios right now. And the reduced risk is basically the situation where you are essentially taking some intermediate kind of level of intervention that will reduce the probability of the undesirable outcomes, but not eliminate them altogether. So then we look at what proportion of people selected the risky or the riskless. You don't have to worry about the reduced option because it's basically says about 1/3 of the time. And you see that as the uncertainty about the probability increases, it goes from 0.4 to 0.6 to 0.8 to 1, people are less likely to select the risky, are more likely, as you'd expect, to take the risk of the vagueness of aversive outcome. But again, it's far from being universal, it's far from being everyone. Here's another interesting thing I think we did. We asked ourselves, are there ways in which we could convey these probabilities to these people that will affect the kind of outcomes that they are doing? So in addition to the group that simply received this instruction and then we quizzed them to make sure they understood them, there was a group of people who, in addition, they saw displays of this type, so they could see exactly what was the consequence of the tree decision for all the probabilities. There was another group who did not see the displays, but they were given a calculator. And they had a calculator when they were asked to make guesses about how likely it is that the probability of red is 0.2, 0.3, 0.4. And once they would enter their guesses, the calculator would give them immediately an answer of what's the expected value of each action. And what you find is that if you comparing the control condition with the display and the summary, is when you present this additional information, you have people taking many more risky decisions, up to 50%. And in particular, when you're offering them this calculator that essentially provides them a prescription for action. So people are very sensitive to the way in which presentation is presented to them. In the final experiment in this series, we did the following. We started by showing people a few trials, a few decisions where they use the calculator, then a few decisions where they use this display presentation, and then for the last round, they could choose the one that they liked more. And what we found, the overwhelming majority of people, when given a choice of one between the calculator and this display, so the calculator reduces the uncertainty, it doesn't give you a single number, and the display presents you all the possible outcomes. The overwhelming majority prefer the display, despite the fact that the calculator is more precise, but the display was perceived as more informative, and therefore people liked it. Again, going against this notion that precision is always preferred. In the next study, we're going to see what are the situations in which people actually explicitly say, I'm willing to pay more for imprecision. And this is essentially, if you remember the congruence principle that I stated, the answer, there should be such cases where people perceive the situation as being one where precision is unreasonable. It's really unreasonable to expect precision, therefore it doesn't pay to seek for it. And this study that I've done with former colleagues at the University of Illinois, who are all accountants in the Department of Accounting, and they presented me with this result, with this fact which I didn't know. Companies that are traded on the market, the management can issue periodical, either quarterly or annually, forecast of what will be the earning for the next period. They are not required by law to do so. Since there's no requirement for them to issue such forecast, they can choose the format of the issues, of the format that they issue. So it turns out that only about 20% of the firms issue precise forecasts, like the earning per share is going to be 3 cents. More present ranges, so the earning per share is going to be between 7 and 20 cents, and most of them present sometimes one or sometimes the other, but also more often imprecise ranges than precise ranges, precise quantities. So we had this hypothesis that, of course, they are doing this because of their ability to forecast, and they are, but also because we thought that they think that their audience, the investors, are sensitive, and they're in some cases, in some situations, they would prefer precise information, and in others, they would not. And therefore, we did some experiment where we looked at this situation from the perspective of the investor. So what we did, we took basically the press releases that this company's issues. We stripped away any identifying information. People couldn't know that this is IBM or Ford or whatever. And we simply used this one paragraph describing the forecast that the company was making. And basically, in some cases, it was done precisely, say 10 cents. In other cases, it was 8 to 12 cents. In other cases, 4 to 16 cents. So it increased the uncertainty. And what we find is that our participants, which in this case were all MBA students at Illinois and at DePaul University, they were willing to pay more, and they were willing to say, I'm more interested in purchase the company that was issuing the imprecise forecast. Now, not overall, up to a limit. This was not a monotonic trend. It was increasing up to a low to moderate level of imprecision. If the imprecision was getting way too large, they would prefer the precise one. But they were communicating to us that they think that in this particular context, there's some optimal level of imprecision, which is the one that they seek and they consider to be optimal. And then when we asked them to make ratings of the various forecasts, they said the imprecise one, they consider them to be more informative, more accurate, more credible. So in other words, the situation is such where people have expectation of what is the precision that you can expect in various situations, and they value most forecasts that are matching in their precision their perceived view of these cases. The last study in this section is one which asks, are all uncertainties alike or imprecisions alike? So imagine again a climate change scenario. In this case, think of a scenario where you are working for Orange County in California, and you are the people who are in charge of the port of Los Angeles, San Diego. There's another big one. I can't remember which one it is. And you know that because of climate change, of expected rise in the ocean level, you have to make adjustment to rebuild your ports. But you don't know exactly how much because you need prescription or projections of what will be the rate at which the ocean will rise. And you go to two forecasts or two experts and you ask for their forecast. So in one case, you have two experts that say, one says it's 20 inches, the other one says 40 inches. In other situation, you have two experts, call them C and D, and they both tell you the same thing. It's between 20 and 40. They're in complete agreement that it's imprecise. And a third case is one of them tells you it's between 20 and 30, the other one tells you it's between 30 and 40. Now, you go to your boss, and he asks you, so what did you hear? And you could say, everyone I talk to, they agree it's going to be between 20 and 40. But in this case, 20 and 40 in some cases reflects conflict between forecasters. In other one, it reflects lack of complete agreement on how imprecise the estimates are going to be. And the hybrid is basically a mixture of the two. And we predicted, based on some other results in the literature, that people are much more sensitive and much more aversive to imprecision that is due to conflict than to explicitly express lack of complete knowledge. So this is just the scenario that I described earlier. That's the details, so I'm going to skip it. And what we find is that people, when asked would they willing to purchase insurance for situations in which their estimates are going to be wrong, they're willing to pay more and to buy insurance more often when they perceived that the disagreement was a reflection of conflict, that when they judged how confident they were in their estimates of the situation, they were least confident when there was conflict. And the hybrid was always somewhere in between. In fact, here is a rating of all the three situations where the red line at the top is imprecision, the blue line at the bottom is the conflict, and the green line in between is the hybrid. And you see that the conflict is judged to being the least precise, the most ambiguous, the least complete, the least informative, the least credible, the hardest to reconcile, and so on. So let me summarize this first part of my presentation. Overall, people prefer precise information, but the strength of this preference was overblown and oversold. I've heard some of the most distinguished people in the field telling us that often experts are reluctant to provide their true opinion to decision makers because they think that everyone expects them to be precise. And if they display any kind of either uncertainty or explicit statement, the best I can tell is going to be between A and B rather than precisely the single value, they are going to be dismissed and not taken seriously. I think that this is a wrong conclusion. People are sensitive to a variety of things, the nature of the event, the type and source of the uncertainty, and how you represent it. And to repeat, people expect and prefer uncertainty to be communicated in the way that is congruent with the nature of the event and its uncertainty. So moving to the second part of my talk, which, as you'll see in a moment, has a lot in common, but it's a totally different type of study. So global climate change is a serious problem, probably one of the most critical problems that we as a society face. And there is an almost universal and almost unanimity among the scientists working in the field that it's real, it's happening now, it's serious, and it's mostly, not exclusively, of course, man-made. This perception or this unanimity around this conclusion is not necessarily shared by policymakers and also not by the public. And the public also thinks that the scientists disagree more among themselves than they actually do. And the reason I find this very troubling is because, and I don't want to get political, but there's a certain group of people who are using, in this particular case, uncertainty strategically. In other words, they basically are making the argument, because we don't know things to the certainty that we would like to have, we better don't do anything and wait. And wait until we know for sure. But when we know for sure, it will be too late to act. So this notion of that uncertainty is being used in an unscrupulous and strategic way is the one that I think we should be concerned about. And here's what, to illustrate this, I'm presenting here a variation of the famous hockey stick figure that Michael Mann presented. And basically this shows the global temperature starting from the year 1000 to the year 2000 and with projections for the next 100 years. The red line is the best estimate of the global temperature, and this area around it, the gray area, is the uncertainty about this estimate. And you see it's less, of course, the farther you go into the past, the more uncertainty there is. Now, look what happened after the year 2000, where we talk about the future. There are various models, different colors, that predict different outcomes. You know, it's going to increase by 3 degrees, by 5, by 4.5, and so on. And not all the models agree, and each one of the models has its own uncertainty. But there is no model that predicts that it's going to stay flat or that it's going to go down. So to bring uncertainty as an excuse not to act is basically saying, no, there must be another model that everything stays flat or goes worse. So how do we know as a public about climate change? This body was established called the Intergovernmental Panel of Climate Change, IPCC, was established by the UN and the World Meteorological Organization. And what they are doing, they are basically gathering all the evidence, summarizing it, and they are publishing periodically assessment reports. In fact, we are now, this year, one chapter after the other, the 5th assessment of this IPCC is coming out. And they've struggled from the very beginning how to communicate uncertainty to the public. Because you must realize there are people there who are economists and others who are physicists and others who are climate scientists. They come from different disciplines. They work in different domains. Their way of thinking about uncertainty is different. And they didn't want to make the report basically a combination, a mixture of different ways. And they had to compromise on something that they all could use. And here's what they've been using. This is a table that if you write for the IPCC or if you're reviewing the IPCC, you'll get a document explaining to you this table. If you just go to the website, which I encourage you, and download for free some of the reports, you'll find this table in an appendix or in a footnote in every single report. It basically tells you we're going to classify uncertainty into 7 categories, not equal. Okay? So whenever you read likely, in any other publication, likely means more than 66. Whenever you read very unlikely, it means less than 10%. Okay? So that's the way in which the reports are being written. I've done lots and lots of work, probably too much for my own good, about how people understand and work with probability words of these types. And here are some of the results that we have in our work. First of all, there's a huge, amazing richness of expressions of linguistic expression of probability that people have, especially in English. In some studies, we get up to 100 or over 100 expressions when people put together all kinds of adverbs and adjectives and so on. Secondly, people interpret these results in different ways. I mean, if you ask people, what does likely mean, you get a huge variability in interpretation. The interpretation that people attach is sensitive to context. Okay, the likelihood that Washington University will win the Pac-10, we say it's likely. What do you mean by this? Or if you talk about likelihood of cancer, though it's the same word, people will assign to it different words because depending on the context, on the base rate, they will interpret these results. And it's extremely difficult to standardize or legislate language. It's very hard to go people and tell them, from now on, you only say likely if it's more than 66% and to enforce it. Now, in very narrow professional context, it can work. So the National Weather Forecaster, they have a scale with 10 categories, and they use it professionally to communicate with each other very, very well. But my colleague Tom Watson did the study. It was National Weather Forecaster professionals and asked them questions about the meaning of likely and unlikely in context outside their own expertise. You know, you go to the doctor and he tells you that it's likely going to have a knee replacement, or it's likely that you're going to have the operation to do that. And the moment you take the expressions after the professional context in which you're trained to use them in a particular way, everything goes out the window and they basically act as everyone else. So all these things together, they are to create this illusion that we can communicate well. But if you remember that not everyone understands the words in the same way, and people are sensitive to their own knowledge and biases, in fact, it's just an illusion because one person likely is another person very unlikely. So my former students, Steve Rommel and Han-Hui Por and I, did a couple of studies in the United States in which we wanted to see whether people who read this IPCC statement understand them and internalize them the way they were intended. And in particular, we proposed that rather than using that scale, we should use what we call a dual scale, where in fact you present people not only the words, but the word and their probability range jointly. So they see both of them. This should not bother everyone. If you like numbers, you look at the number. If you like words, you look at the word. It's very easy to implement. I'm not going to show you the results of our studies, but rather I'm going to show you the results of the most recent studies that we just completed, which is essentially an international study that we've done to study exactly the same question. We argued, climate change is global. This is a problem that affects everyone all over the globe. These reports are read in the United States as they are in France and in Italy, in Japan, in Korea, and so on. If you take these words, this table, and you translate it into various languages, who knows, maybe you introduce more variability. So we wanted to study whether these statements are understood identically everywhere in the world. Question two, whether differences between countries can be explained to the degree to which people in various countries believe in climate change, endorse it, and so on. I will not have time to say anything about this. And then we wanted to see whether this alternative scale that we are proposing is indeed superior in the sense that it makes communication more effective. So what we did, I'm going to talk about some details of the studies. We selected 8 sentences from one of the reports. 2 of them use the word very likely, 2 the word likely, 2 very unlikely, and so on. We didn't use any sentences with the very extreme words simply because they are never used. I mean, in principle, they are there for people to use them, but the report never used it. And then we asked people for each one of these sentences to read it and to tell us what do they think was the probability that the authors meant to communicate, their best estimate, their best guess, as well as a lower bound and an upper bound of these probabilities. And we had 2 groups. One group, we basically presented them with this statement as they were and gave them the possibility to read the translation table. And the other one, we actually used this revised format where the words and number were used together. We did also a bunch of other surveys about beliefs in climate change and how numerous the people are, but I don't have time to talk about this. You have to invite me again. So here are some examples of the sentences that we used. Sentence 1, if you ignore for a moment the green in parentheses, it's very likely that hot extreme heat waves and heavy precipitation events will continue to become more frequent. So that's a statement taken from the report. And if you are in the dual condition where you saw both of them, next to very likely, it also immediately said greater than 90%. Question 2, the Greenland ice sheet and other Arctic ice fields likely, which means, remind you, greater than 66%, contributed no more than 4 meters of the observed sea level. So if you are in a translation group, you would see this display with the sentence at the top, and then a reminder, we don't want what you think, we want what is your understanding of what the authors meant, and then your slide, these sliders, minimum, lower bound, best guess, and maximum. And if you are not sure what the words meant, you could push the button that says, click here to view the IPCC guideline. This would pop up. Then you could go back and make your judgment. And if you are in the other group, there was no table. Simply the table was, so to speak, embedded. It was part and parcel of the presentation. So we sampled people in 27 countries. We were aiming for 400 people in every country, half of them assigned to the 2 conditions. For every country that we sampled, we had local collaborators who translated and then independently back-translated back into English to verify that the content was maintained. For a couple of reasons, we had to drop 2 of the countries, and we end up, what I'm going to show you next, are results from 10,239 participants in 25 samples in about 19 countries, because there are multiple. In some countries, we used 2 languages, and English was used in several countries. And notice that the participants are real samples from the population, about half of them men, and the mean age was over 40. Okay, so this is, in some sense, the most interesting result. What I show here is for each one of the 4 words, what we call box plots. And the way to interpret this plot is the following. Within the central box, 50% of the judgments are within the box. These extra whiskers that you push upwards or downwards, they cover the central 90% of the population of the estimates. So the most extreme 5% are excluded, and the plus sign everywhere is the mean. So here's the word very unlikely, which according to the IPCC report means less than 10%. But of all the participants, these are the only estimates that are under 10%. In fact, people estimate very unlikely to be much, much closer to 50% than intended. If you look as very likely, which is in principle should have been above the top dashed line at 90, you see only about 15% or 20% of the estimates are above that line. People really think of likely more like 70% or 80%. So that's the bad news, that people are very conservative in their interpretation, which means that they were going to downplay your estimates. They are never going to interpret them as extremely as you want them to. The relatively good news is, just as Susan saying, it's not that they are doing anything optimally, but they are doing things slightly better. If you look for each word, the darker box plots are what happens when you are using words and numbers together, and you see that for the long words, the distribution is pulled lower, and for the positive words, the distribution are pushed upward. So in other words, this pushes things in the right directions, so the words are much, much better differentiated. Here's an example of what we mean by better differentiated. We calculated for each country what was the median range, the difference between the median value they assigned to very likely, the highest word, to the very unlikely. And we did it separately in the translation condition and in the dual condition. If there was no differences, each country is a point, and some of them are identified. If they were identical, all the points should be on the diagonal line. If they were random, they should be all over the place. As it is, all 25 countries are all above the diagonal, indicating that under the new presentation format, the words are better separated, they are more spread, and they span wider ranges. In this case, in this plot, thank you. In this plot, we are presenting the proportion of estimates which are actually imperfect compliance with the IPCC guidelines. And you see again, the bad news is it's low. It is particularly low for the extreme words, very unlikely to very likely. The relatively good news is that the new format increases the compliance with the intended communication for all the words, and especially for the more extreme ones. So for where 16% in the translation group comply with the instruction, almost double, 32% in the dual presentation achieve the same result. Here is the level of precision, the level of consistency with the guidelines for each one of the countries in our sample. On the left-hand side, ranked order from the worst, India to the best, the Hebrew-speaking Israeli sample, it's under the translation. On the right-hand side, it's under the dual presentation. In each and every single country, this new format improved dramatically the rate of compliance, in other words, the level of communication. I mean, the effectiveness of communication. And here's the most interesting result, which is, well, I don't have time to go into the details, but I'll give you just the gist. We looked at how, no, you missed, that's 13. Okay, so I'm going to skip this. I don't have time to explain. To summary, okay. The public consistently misinterprets the probabilities as communicated by the IPCC as less extreme than intended. There's very large variability, and in fact, the variability in the interpretation is larger than the variability in the communication. You may have said, what likely means everything about 66 is likely? That's a huge range. When in fact, the public, when you ask them what did they mean, they think of even a wider and broader range. It's possible to associate some of these misinterpretations with certain feature of the public. I don't have time to describe it, but if you ask me the right questions after in the Q&A, I'll show you that. These results are remarkably and surprisingly to me stable in all the samples and all the languages. So what are my recommendations to the IPCC? And now when this paper is actually now about to be published, is accepted, I think that I can try again for the third time to convince the Committee of Uncertainty Communication in IPCC to take these results seriously. Try to use probability pronouncements only about events which are really very precise and unambiguous to eliminate the problems with ambiguous events. It's possible to continue to use the 7 words in the table, but they need to refine the boundaries for the various words to make them more consistent with the way people actually use these words. The sad truth is that if you look at the composition of the committee who made up this table, there was not one social scientist among them. They're all scientists. They basically relied on the intuition, likely, 66%. And no one bothered to say, let's do a survey. Let's see what people mean, how people understand the word likely. Now we have so much data, it's no longer need to do a survey just to implement the results. And of course, adopt the dual format that we are proposing. This format has positive effects in all the samples and for all groups. It appeals to all, regardless of what your favorite modality is. And it has another added benefit, which I didn't discuss. Since every word is going to be accompanied by a range of values, now you can have the flexibility of not always using the same values. See, sometimes you want to mean likely, but you know that for this particular context, likely can be defined more narrowly. Although likely as a rule is more than 66%, you have the option of saying, in this case, likely means only between 60 and 75. And there's something that's always been in the back of my mind. I have no way of testing it. I mean, the idea is that this is what the IPCC tells to all the people who write, but the IPCC can never really test or check whether people who are writing are following these rules. But I think that if you're going to implement this kind of format, then it will also serve as a reminder to the writers, and not only to the readers, to be more consistent and in line with the guidelines. So I'm going to skip this, And I'm just going to finish by acknowledging that NSF was very gracious and generous in supporting my work over the years, and to all my collaborators and current and former students. So thank you very much. I'll be happy to answer questions.
Thank you very much. Thank you very much. There's actually a lot of different questions.
Okay.
And so again, please come to the microphones. And actually, there's people already right there. So I'll go ahead and start calling on the first person.
Okay.
I'm kind of curious if, as a result of your work in your daily life, you find that in dealing with people and they use these sort of qualitative expressions, that you constantly ask them to clarify or elucidate numerically what they mean. If you do in your life, and moreover, what the result is of that kind of communication, if you find that it leads to more effective communication or you drive people crazy,
Let's
or...
say, I have a history of annoying 2 or 3 physicians who said, well, yeah, this hernia operation works very well. Usually, or very, very frequently, everything works very well. And when I push them by what I mean by very frequently, they get very annoyed. But I don't want to generalize. I mean, quite often, you need to remember that this is a 2-side communication. The fact that people sometimes like to use this word is because they think that that's what other people want to hear. And I also come across physicians who, when you ask them, can you be more precise and quantify, they are very happy to do it, and also to tell you, oh, I'm so glad that I have patients like you who ask me this kind of question, because most people don't bother.
But I mean, it's when somebody uses the word likely, I assume in my mind that they know what they mean by likely, but they're not stating it. And I mean, my tendency would be to say, what do you mean by likely?
That's right.
But I found that with certain demographics, I get myself in trouble.
So let's not talk about demographic, but the most famous example of this is the debriefing that took place in the White House between President Kennedy and the CIA after the failure of Bay of Pigs invasion, when they were using words of this type, and when in the debriefing said, oh, likely we meant 40 to 50%, and the decision makers, in retrospect, of course, everything was in retrospect, said, oh, we thought we meant 70 to 80%. Yeah.
Go ahead right here.
Yes.
Hi. The book Merchants of Doubt gives well-documented evidence that you know about that.
Yes.
Yeah, right.
Feel free to tell everyone else.
How does that, I mean, the fact that the energy companies have given systematic disinformation to confuse the public, how does that affect your work?
It hasn't so far. No, I mean, I think, as I said, that I was able to find support for my work from federal agencies, and I have no problem publishing these results. But I mean, I inserted a few political statements, but you won't find any of these things in any of my writings on the topics. So the topics are finding just the way we operate, and the fact that climate change is one case where people put a lot of money in order to make things happen or not happen. It's almost a separate issue.
I don't know. It seems as though outside influence would affect just straight probabilities.
Well, okay, so let me show you one more graph, since you asked the right question. So, I'm sorry? So, in the United States sample, where we all understand the political system, we ask people on a scale of 1 to 7 to identify themselves in terms of their political affiliation. And this is the interpretation of the words very unlikely, unlikely, likely, and very likely. The red line is people who said on a scale of 1 to 7, 6 or 7 Republican. The blue line are people who say extreme, very or Democrat. And you see that the same sentences, the same words, in about 150 people in each one of these lines, the Democrats assign probabilities higher by 15 to 20% to each one of these words. So there's another message there, and which I think is an important message to people who communicate uncertainty. We may think, I'm the expert, I've done all the analysis, and here's the result. Use them, accept my estimates, my forecast, and put them to work. But in fact, quite often when we communicate this, people have already beliefs of their own, have expectations of their own, and they use the information that you are providing as an additional piece of information. They may discount it to various degrees depending on how close they agree with you. So what we are communicating in a Bayesian sense is not a posterior distribution, as we would like to say. We're just communicating another piece of evidence that people are going to use in order to update their beliefs. Yes?
It was notable the degree to which India and Israel were outliers in your data. Was that your excellent Hebrew translation, or was there something else going on?
No. I'm trying, I don't want to make very much out of this, the differences between various countries. Because to be perfectly honest, we pay this company, Qualtrics, to recruit participants in every country. They are not doing what, in the various countries, what you would call complete random representative probability sampling. They have their ways of finding participants in different countries, and they are using them. So I think we've gone way, way above what everyone else has done in trying to get to standardize and collect data in many, many countries. We haven't gone to the point where I can look at 2 points that that's why Korea is different from Japan or Israel is different. So I don't think that the data will allow me to make anything of that type. Yeah.
Thanks.
And by the way, the two samples we dropped were the two Arabic-speaking countries, the Israeli Hebrew, the Israeli Arabic sample and the Egyptian sample, simply because in this process, the participants that we got from there were 80% men, and all of them were under the age of 30. So in terms of the composition of the sample, they were so different from all the other samples that I decided to take them out. Although everything that I showed you applied to them as well, but they were different in that sense.
Thank you. Are there any other questions? I might ask now my one question, actually.
Okay.
So I was really struck earlier in the talk about how individuals seem to prefer a certain amount of uncertainty to having some concrete piece of data shown. So I'm wondering why is that? Is it that because there's actually a greater chance that that single piece of data is going to be wrong, and that they feel more confident in having range?
So in the same paper about preference for vague forecast, we had a survey where we asked people, you go to your doctor and he tells you the chances are 60 or between 40 and 50 ranges, and you say another situation where instead of going to the doctor, you basically say your senator thinks that the probability that this bill will pass in the next year is going to be the same numbers and the same ranges, and so on. So, and if you look some financial forecasts, and I think you see that people have different expectation of what kind of precision to expect, for example, in medical advice, and I would guess, I haven't done it in scientific, and they have expectation of what is the level of predictability or forecastability in different events. And I think they just don't believe, based on their lifelong experience, that in predicting political or geopolitical events or in predicting how well a particular stock will do on the market, it's reasonable to expect the level of precision. And so I think that that's basically a reflection of what they think is the natural level of imprecision they would expect in particular domains.
So then as you go from teenagers up to the older age, you probably see then a difference.
Yes,
if it's
although
based
I must
on
confess
experience.
that I got to the point where I don't like to do comparison across ages.
Okay, okay. Sorry to bring that up. I understand. Okay, anyway, thank you again for coming.